I became pretty convinced that God was just a psychological crutch. Those were very dark thoughts when I was a freshman in college, but that was where I was. And I remember I said, God, I don't know if you exist, but if you do exist, you have to prove it to me because I'm a scientist. I just can't do this blindly. And what happened, interestingly enough, is the more I would study, the more I would realize that a little science will often take people away from God. And this is a very famous quote, but a lot of science brings them back. Thank you. It's really an honor to be here. And I'm going to be talking about my favorite topic through this conference, and that's the evidence of design in biology. And just to give you a little bit of a background, this is a really significant topic for me because I grew up in the church. I went to Mass every week. But when I went to MIT undergraduate, I became pretty convinced that God was just a psychological crutch. And the person who had a lot of influence on me in that is a man named Richard Dawkins. Who's heard of Richard Dawkins? Yeah, he's one of the patron saints of atheism, so he's a very popular figure. And I read his book, The Blind Watchmaker. And people are more familiar with his more recent book called The God Delusion. I don't think I have to explain to you the content of the book. But in this less well-known book, he talks about how when you look at nature, you think you see design in the world, but it's just an illusion. Everything is just the product of chance, time, and natural processes. And that convinced me that people probably could be categorized as two types of people. One were people of faith that were more fluffy in their beliefs. They kind of just accepted things blindly. It's just a bunch of tradition. And then there were people of science that were objective and rational and explored the evidence. And I kind of wanted to be a person of science. So I thought this religious thing was just kind of just as something of no real value, just something for people that were intellectually weak or lazy. And I remember that was a little disheartening because what I realized is if that were the case, if God didn't exist, if religion was just a crutch, then life really has no purpose. Because if I'm just a product of the blind forces of nature, then it really doesn't matter if I'm happy or if I'm sad, if I'm kind or cruel, because I'm just going to die and my memories will cease to exist. And then eventually our planet our sun will explode and all life will cease. Those were very dark thoughts when I was a freshman in college, but that was where I was. And I remember I said, God, I don't know if you exist, but if you do exist, you have to prove it to me because I'm a scientist. I just can't do this blindly. And I didn't know if that was against the rules. I'm not a theologian. I didn't know if that was illegal, but I just said it's kind of the way it had to be for me. And what happened was God really honored that prayer because I said, God, if you prove to me what's true, I'll follow you with all of my heart. And that put me on a path of many years where I studied science and philosophy to a little extent. I studied the issue of evolution, the issue of the origin of the universe, comparative religions. And what happened, interestingly enough, is the more I would study, the more I would realize that a little science will often take people away from God. And this is a very famous quote, but a lot of science brings them back. Because when you look at physics and chemistry and biology, what you see is evidence of design that's everywhere, and it's very, very clear. And also, what I realized just learning about the resurrection, the history behind the faith, it's just the evidence is very, very strong. So people that are resistant to faith, it's usually not the evidence, there's other reasons. And part of that reason I realized over time was it's really the story we live out, right? Anyone see the movie The Matrix? It's one of my favorite movies. It's about these probably overly ambitious scientists that create these robots to take over the world. And what they do is they plug these electrodes in people's brains and they project this false narrative of reality, the Matrix. And everything seems so real to them, but eventually what happened was there was a man named Neo, and he was unplugged from the Matrix. And that's the challenge that you find, I think, with education. And that's why I so appreciate classical education, because what you're doing is you're teaching people to break free from the matrix that surrounds them, from TV commercials to media, telling them that the world is an accident, you have no purpose in life except to make money and to be happy, and whoever dies with the most toys wins. And you're teaching people how to see the world for the way it truly is. And that is the greatest gift you can give children. So what I'm going to do for you today is talk a little bit about the science, because the science is the foundation of our faith in many ways. Like, what does the creed begin with? In the beginning, God created the heavens and the earth. The idea that God is creator. And if you get that foundation wrong, you get everything wrong. Because if you don't know that God is our creator, you end up with people like this, who's Lawrence Krauss. Lawrence Krauss is a physicist. He's an atheist. And he says, we constitute a 1% bit of pollution in the universe. We're completely irrelevant. And he's probably not going to be the next graduation speaker for your school, but what he's saying makes perfect sense from an atheistic perspective. And if that's the foundation for ethics and morality and law in business, there's going to be some real issues in society. There is real issues in society because this is what people believe, that we are just an accident of nature. And what I learned also was that when you look at the scriptures, is you really see the same conversation that has been taking place for 2,500 years. Because the question about design and nature doesn't go back to the Scopes monkey trial. It doesn't go back to origin of species. It goes back to like 2,500 years to the debates between the philosophers like Democritus and Plato. And I won't go into this because I believe Logan Gage will be talking some about this. But the key is way back in the beginning of philosophy, people were debating whether the universe was just an accident, if everything we see is just chance and time and natural processes, or is there a mind behind the universe? When you look at the order of our planet, our sun, when you look at the order of life, can that be explained purely through natural processes, or does it show a mind shape the world for a purpose? That is the ultimate question. Paul addresses this in his famous letter to the Romans, where he talks about how since the creation of the world, God's invisible qualities, his eternal power, and divine nature have been clearly seen, being understood from what has been made, so people are without excuse. It doesn't say that people won't have their excuses. There's lots of excuses, but it does say they will be without excuse. And this perspective shaped Western civilization. It was just taken for granted for hundreds of years that the world was designed, that we were designed. What happened, though, is when you have the rise of modern physics, the rise of Newtonian mechanics, electromagnetism, what people realized was that you could really explain so much of the world with a very small number of equations. So that gave more credence to the materialist tradition, but still, that didn't challenge the faith because, as you just heard in the previous lecture, many of the founders of modern science were Christian, and it was their faith that allowed them to do science. But that changed dramatically. Part of it was that you had the rise of very skeptical philosophers, the people like the David Humes, people like the Voltaires, people like the Rousseaus. But what happened is on that tailwind of these various philosophical trends, you have the idea of Charles Darwin and the origin of species. And what he did was he essentially gave an alternative creation story. So instead of the Christian faith, the Catholic catechism that talks about how creation, at the start of creation, God spoke, and it was through his will that creation came into being, according to his design, Darwin gave an alternative story, and that was that life is a product of blind, undirected processes that had no goal in mind. And what's happened is that story has essentially swept through Western civilization and culture in the power centers of education and politics. And this is sort of the official story that you're given wherever you look, is that simply nature is a product of blind chance. What's happened, though, is the pendulum had swung pretty much to this materialist tradition, but it's starting to swing back because what you find is the science is increasingly pointing to a mind. And one of the areas where that's most clear is in physics, because what happened is the materialist tradition depended on this idea that the universe was eternal. Because the universe was basically infinitely old, you had all the time you needed for chance and natural processes to produce anything imaginable. But as it turns out, that's not the case. With Albert Einstein's theory of general relativity, he came up with his famous field equations. And the field equations pointed to the fact of general relativity that the universe probably had a beginning. Now, initially, Einstein resisted that because the equations of general relativity that describe how matter bends space and how the bending of space causes matter to move, the equations suggested that there was a beginning of the universe. But Einstein was very uncomfortable with that because he thought the universe was eternal. So he had a term he added to his equations. And it's that little term called the cosmological constant. Now, mathematically, adding a constant is quite legitimate. I won't go through the details of general relativity and how to derive the equations, but I apologize, there's not quite enough time for that. I'm sure you were anxious for that. But if I did derive them, that constant is perfectly fair. But what Einstein did was he set the value to the perfect value to create a static universe. Because gravity causes the universe to compact, the mass in the universe causes the universe to compact, but this constant term is like background energy. It's called a dark energy that causes the universe to expand. He set the value perfectly, so the universe was just always static. And what happened, though, is when people discovered that the universe was expanding because of the redshift, Einstein finally realized that the universe had to have a beginning. He said it was the greatest blunder of his life because if he wasn't so resistant to the universe having a beginning, he could have anticipated the Big Bang. Now, why was there all this fuss about a beginning? Because a lot of astronomers who were atheists said, we do not like the idea of a beginning, people like Fred Hoyle, because it points to a creation event. And a creation event has huge theological implications. Because if time, matter, space, and energy all began, it suggests that whatever created the universe is outside of time and space, with infinite power that created everything in a burst of light. Does that ring a bell at all? In the beginning, God said, let there be light, and there was light. He created the heavens and the earth. So again, they realized that the universe had a beginning. Now, there has been more modern resistance to this, like by Stephen Hawking. And Stephen Hawking, a very famous physicist, said this. He said, because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist. And of course, he realized the theological implications. It is not necessary to invoke God to light the blue touch paper and set the universe going. Now, how many of you see the logical contradiction to what he said? Gravity is not nothing. Gravity is something. It implies a universe already exists. In fact, what I did was I actually went through the technical research papers by Hawking and his partner, Hartle, and I looked at the mathematics. And what I learned from looking at the math, it took me several days, that he does not explain how the universe came from nothing, but he assumes the universe already exists, but it's very small, and then he explains how it gets bigger once it already exists. So the mathematics of Hawking and Hartle, his compatriot, show that time, space, matter, and energy all began, again pointing to a creator. But it goes even further than that. Because what people realized is when you actually study the laws of physics, gravity, electromagnetism, they do not look like they're an accident, but it looks like a mind designed the laws of nature with the purpose of life in mind. It was the purpose for life to exist. And that's really striking. And just to give you an analogy to give you the sense of the implications, imagine someone gives you a mixer board for Christmas. But it's a very special mixer board because this mixer board creates universes. And every dial on this mixer board determines a detail of the universe. One dial turns gravity up or turns it down. Another dial controls the force between electrons and protons. Another dial controls the mass of a quark. Another dial controls the initial order or disorder in the universe, and the list goes on. Well, if you're just to set those dials randomly, you hit the button and you create a universe, there's virtually no chance that the universe you created would support life. To have a universe that supports life, you have to set every dial, many of the dials very, very carefully to have a universe that produces stars and planets and chemistry, and ultimately carbon-based chemistry. That's why it's called fine-tuned. Anyone play like an instrument, like a piano or guitar? What happens if you don't tune your guitar? What if you don't tune the strings so they have the right tension? Or if you don't tune the hammers in your piano? It sounds terrible because it has to be perfectly set for you to produce a meaningful melody. In the same way, if you don't set all the details of your universe right, your universe will not support life. In some cases, the dials need to be set well, but not great. A great example is the force between electrons and protons. It's called the electromagnetic force. If you don't set that value right to about a few percent, so if it's a few percent larger or a few percent smaller, you will not have life in the universe because stars wouldn't be able to produce carbon and oxygen. Also, if you look at what's called the strong nuclear force, and that's the force that holds nucleuses together, it holds protons and neutrons together. If you were to make that force a few percent larger, smaller, no life in the universe. So if you imagine a dial, you might have to set the dial between the dial goes from 1 to 100, you might have to set it between 85 and 88. But if you look at other forces, like the force of gravity, that you have to set right to 1 part in 10 to about the 35. That's like a 1 with 35 zeros. Any of you shoot guns, by the way, just for practice? Now, if I were to ask you, how far could you shoot a target which was, let's say, 1 inch in diameter? If you were really good, you could hit that at maybe 100 meters. If you're Jason Bourne, maybe 2 miles. But the precision necessary to set that dial, the fine-tuning required for gravity to support life, would be like a 1-inch target at the other end of our solar system. To hit that target is the precision necessary for you to have life in our universe. But it gets even more extreme. There's another constant I mentioned, which was the cosmological constant. And again, remember, that's the energy that permeates space. It's what's called the dark energy, and it's what causes the universe to expand. That constant has to be set right to about 1 part in 10 to the 90. That's a 1 with 90 zeros. So that'd be like if you're shooting a target the size of an atom at the other side of our galaxy. That's the precision necessary to set this dial for the cosmological constant for our universe to support life. Of course, the most extreme example is that of the entropy or the disorder in the universe. You have to set the order in the universe correct to 1 part in 10 to the 10 to the 123. Okay, that's a big number. Now, okay, to write that number, imagine you put the 1, you draw the little line, you put a 1, and you put a 0 on every atom in the visible universe. You still couldn't even write that number. That's the precision necessary to create the order in our universe required for our universe to support life. So it's not just a bunch of black holes. This evidence was really striking to a man named Sir Fred Hoyle. He was an atheist astronomer, astrophysicist, and he actually is the one who discovered how stars could produce carbon. He's a brilliant man, and he said a common sense interpretation of the data suggests that a super intellect has monkeyed with physics as well as with chemistry and biology. So again, this atheist, his atheism was shaken to the core because the science pointed to the fact that our universe was designed. Now, of course, the way people get around this, and this would probably be one of the first questions, is what about the multiverse? You've all seen Doctor Strange, right? You know, the multiverse of madness, or you know, whatever your favorite multiverse episode is. And the idea is that there's not just one universe, but there's lots and lots and lots of universes. And every universe has slightly different laws. And we just happen to be in the universe with Dr. Strange, who lives in New York, and with the laws of nature that are right for life. We just won the cosmic lottery. That's the idea. But there's a slight problem with that. Even if you assumed there was some multiverse generating machine that produced all these universes, you'd have to explain how the machine worked. And that's what people do. So people who are cosmologists, they have things called like eternal inflation. They have things like string landscape theory, which is cosmology combined with string theory. But what they found is that to devise a multiverse machine, a multiverse theory that generates universes that could potentially generate ours, you have to fine-tune the parameters of that multiverse as much as you have to fine-tune our universe. So the evidence that you have to design the universe is inescapable. It's kind of like, if you ever have a rug and you have a rug that's too big for like a room, well, what's going to happen with that rug? A little bulge is going to be there, right? What do you want to do with that bulge? Oh, you want to get a hammer and you want to knock that thing down. But what happens as soon as you hammer down the bulge? Boop, it appears someplace else. In the same way, every attempt people make to get rid of the evidence of design in the laws of nature, they simply move the need for design someplace else. Like in the multiverse theory, it still has to be fine-tuned. So the evidence of design is inescapable in the laws of physics. But it's not just that. Because when you look at the details of our planet, you see just as amazing evidence of design. Because to have a planet to support life, even if all the laws of physics are perfect, which they are, is still exceptionally difficult. For a planet to support life, it has to have the right size, the right distance from the sun, the right rotation rate, the right tilt. Because if you don't tilt it properly, either you're going to have just super hot equators and super cold poles, or it might be tilted so much that the weather would be completely unstable. So you need just the right tilt to allow for seasons that allow for a stable environment so that you can have life from the equator to the poles. So the optimality of life we see in our planet is only there because of all this amazing fine-tuning of the details of our planet. Here's another example. We have to have a moon just the right size and just the right distance to stabilize the tilt, or else you'll have unstable weather patterns. Here's another example. You have the atmosphere. Because one, you have to have a sun that produces just the right energy. You want light, you want infrared, which is heat. You don't want X-rays, and you don't want microwaves. So you want just the right light and heat, which is what our sun produces. You have to have a sun that's very stable, so it doesn't produce solar flares all the time. But then the atmosphere has to let the right type of energy through. So our atmosphere is perfect because what it does is it allows light through, visible light, which we need for photosynthesis, for seeing. It allows heat through, but then it blocks things like the X-rays and the microwaves, which would kill us. So again, we've got the perfect atmosphere. And what's also amazing is when the energy from the sun hits the earth, it re-emits it at a different frequency, and the atmosphere is also perfect to allow the re-emitted heat to escape at just the right amount so that we have just the right temperature. So there's amazing things with our atmosphere. Also, we have the perfect amount of oxygen. If we had too little oxygen, we couldn't have enough energy for being very active. But if you had too much oxygen, it would cause your body to rot. Like, you ever see like an apple core in the air? It decomposes because too much oxygen is bad for life. So we have just the right amount of oxygen to live. We also have very large outer planets like Jupiter, Saturn. If we didn't have all these large outer planets, asteroids would hit our planet much more often. And that would be bad if you've seen the disaster movies. Instead, the asteroids go right to these large planets because the gravity kind of is like a vacuum cleaner that cleans out our solar system to keep things safe for us. Also, what happens is there's high energy particles that come from the sun that are charged. Well, it just so happens that our planet has a rotating a magma, which is charged, so it creates a magnetic field, and that magnetic field is like a deflector shield that protects us from the harmful radiation that's charged from the sun. Without that magnetic shield, life would not do very well on our planet. Also, what's really amazing is we have large amounts of water on our planet. We have to have large amounts of water for us to have lots of life on our planet, because that's how you get this water cycle. But it's not just that. But the water has amazing properties because of the fine-tuning of the laws of the electromagnetic and the strong force and the masses of quarks. But everything is designed so that water has unusual properties. One is it has a high specific heat, which is essential because the fact that our water has such a high specific heat means that the energy from the sun is absorbed by water, but the temperature of water doesn't change very much. So it keeps the temperature of our planet very stable, not to mention the currents that we have that move the heat around our planet. Also, because of the high specific heat of water, our bodies can absorb a lot of heat but keep the same temperature that allows us to keep a stable metabolism. There's a low ice density, which is very unusual. Most fluids, when they freeze, they become more dense, so they sink. But what happens, because water actually floats when it freezes, that allows for there to be life in the oceans and lakes. Because if ice did not float but it sank, you'd have lakes in the ocean that would freeze from the bottom up, and there just wouldn't be life in the ocean then. But instead, you have this nice layer of ice on the surface, which acts like a blanket, which protects what's below. Also, what's really amazing, it's not just that our planet seems designed for life, but it also seems designed for scientific investigation and cultural advancement. Because as John talked about, you have to have fire for technology. But why do we have fire? We have fire because we have the perfect atmosphere. If we had too much oxygen, fire would burn down our forests. If we had too little oxygen, you couldn't produce much fire. We have just the right amount of nitrogen because nitrogen acts like a fire retardant, so it prevents fires from burning out of control. And again, it also goes back to the laws of physics and the nature of organic chemistry that it actually produces large amounts of heat. But one of my favorite examples is actually the eye. Because what happens is vision, high-resolution vision, depends on a multitude of design parameters that are carefully set. Because what happens, I mentioned before, how visible light penetrates our atmosphere. Visible light is what's largely produced by the sun. Oh, as a side note, visible light and heat also penetrate water. So water is also designed to allow the right radiation through and to block harmful radiation, which is really nice. But also, as it turns out, the wavelength of visible light is perfect for the optics of the eye. So what will happen is light produces a very sharp image of high resolution on our retina. But if it were the case that the wavelength were much longer, our eyes would have to be the size of football fields for us to have high resolution vision. And if the wavelength of light were too short, that would cause problems too. Also, it turns out that if you look at the photoreceptors, that's what receives the light. You have to have a photoreceptor of a certain size to detect photons of varying intensities. So what happens is that the smallest size a photoreceptor can be results in a resolution of vision that perfectly matches the highest resolution from the optics of the eye. So what you see is a convergence of design parameters in physics, in chemistry, in biology that allow us to have high resolution vision, which is what allows us to have technology and a cultural advancement. So again, that's just a beautiful picture. Now, also, for our planet to support life, you've got to have plate tectonics. Because what plate tectonics will do is it will recycle materials like carbon to make sure that we can maintain a reasonable amount of carbon dioxide in the atmosphere and to maintain other important materials at the right amount. But plate tectonics doesn't just allow us to live. What plate tectonics does is it actually works together with other geological and biological cycles to super concentrate important materials like things like gold and iron near the surface of our planet. If we didn't have plate tectonics, if we didn't have the right dynamics of our planet, you wouldn't have large deposits of fuels and minerals and precious materials that are essential for technology, which is absolutely amazing. In fact, there's even organic life like bacteria that will also help to super concentrate metals and other important materials for technology for us. Also, what's amazing is biology produces lots and lots of different minerals. We have far more minerals on the planet Earth than we would on Mars because of all of life, like 5,000 different minerals, many of which can be used in advanced technological applications. So here again, we see that our planet is designed not just for living, but for technology. And what's also really extraordinary is that when you look at the advancement of science and technology, it's amazing that it appears to be designed on our behalf. Because what happens is even people without a lot of technology can easily produce energy with fuel, with wood. They can produce stone tools. And what you can do is with that fuel and with those tools is you can produce more advanced tools. Like you can use fire to melt metal to produce metal tools. With those tools, you can advance in our understanding of science to produce things like electricity. Then once you advance to that level, you can use those tools and that energy to study even deeper physics like atomic physics. And then with that knowledge and with the tools that come from that, you can then study the more foundational physics of particle physics. So it's almost like there's stepping stones where one energy source is accessible to us and one set of tools that is accessible to us allows us to advance technologically and scientifically until we can go from the Stone Age until the Space Age. And of course, as John West talked about, none of this would be relevant in terms of technology if we didn't have the right human body. I talked about the high resolution vision that's essential to advance technologically, but also our hands have a dexterity and precision which is very, very different from other primates. We can hold tools, we can play the piano, we can manage electronics. We also have much higher resolution vision than most other animals. Eagles have better, but that's because they fly in the sky and have to find rats. But we have incredibly high vision. We have special abilities in our vision. We have the ability to speak. The reason we can speak is because there's very complex neural networks that go from our hearing centers to our vocal centers. You don't see that in chimpanzees. You do see it in parrots, and they're very similar, interestingly enough. What happens, though, is our ability to vocalize also helps us to advance culturally. We have upright posture, which allows us to manage tools. We have less hairs, so we can sweat more and work harder. So there's many, many features about the human body that allow us uniquely to advance technologically, not to mention our language centers and our advanced brains. So why is this relevant? Let me use an analogy. Imagine you're walking through the woods and you come to a cabin. And in this cabin, you find that it has all your favorite clothes in the closet, all your favorite food in the kitchen. And then you notice you have your pictures of your relatives and friends on the wall. And then there's a cell phone with your best friend's numbers programmed in order of preference. Now, most of you wouldn't say, wow, what an amazing coincidence. Now, you would say, somebody knew you were coming and designed everything with you in mind. In the same way, when you look at the design of the laws of physics, when you look at the design of our planet, you look at the design of the human body, what is clear is that a loving creator knew we were coming because God created us and designed everything here with us in mind. Thank you.